Thank you all for showing up. We are here to talk about a cross-platform, cross-tool Ray on Kubernetes deployment. Yay! Don't everyone get too excited. And this is going to be very enjoyable. And by that, I mean definitely not a dumpster fire. I'm Holden. I'm an open source engineer at Netflix. Use Ray at Netflix. I also am working on a book about Ray and using Ray for some personal projects. And so there's sort of going to be a mixture of different contexts that are going to float through here. And I'll try and make it clear when I'm talking about the different things. Queer as fuck. Oh, I probably shouldn't have sworn. Queer as frick. And that's just because it's not related to Ray. There's no secret gay garbage collector hanging out that we've been hiding from y'all. But it's just important to me that we all talk about where we're from and the different communities that we're in, so that as we're building these open source communities, we realize sometimes maybe we hang out with people and we're like, oh, we're all the same skin tone and from the same university. Maybe we should get some different folks involved in this project. And I think that's super important for machine learning and data projects and stuff like that. I'm also a dog mom. You can see the picture of myself and Timbit. Timbit is the reason why I still have to have a job, and also the reason why I bother to wake up in the morning. So shout out to my dog.
And I am Kyle. I'm an open source engineer at Tabular. I also previously worked at Tinder, where I did a lot of data things, as well as machine learning, search, trust and safety, a number of things I would probably get in trouble if I spoke about. So I'm also pretty queer. I'm also gay, so that's good to know, to have some diversity in the room, especially as we know with some machine learning output can be a little skewed if not careful. And then I'm also a dog dad. That is barely a picture of me and barely a picture of my dog, as much as I could force him to be in the photo. All right. And then I'll take it from here. So what are we talking about? This is, we're talking cross-platform. So by that we mean we want to be running both ARM instances as well as x86 instances, the ones we're traditionally used to. And then cross-tool. By that we mean we have Spark in the mix for reading, munging data sets, Dask, TensorFlow, CUDA, potentially Apache Iceberg, which I work on with my employer, as well as running this on Kubernetes, which can be a great way to run your infrastructure. It can also be give you enough rope to hang yourself. Some people spoke earlier yesterday about KubeRay, which will be a great way to help minimize some of those issues, but we did this with just traditional deployments and stateful sets. And then also, of course, we're talking about Ray, general purpose distributed system. So if you're new to Ray, welcome. Welcome to the party. We're glad to have you. And so our general focus area is on data sets. We both work on the Spark, in the Spark community, on Apache Iceberg. So I'm very focused on reading in data, reading out data, probably a join or two here or there. And then also, Holden has a special interest in satellites in space.
Yeah.
That we will get to. So what makes this a hard problem to be running Ray on multiple types of machine architectures? For one, Ray doesn't yet have a multi-Linux architecture container. Nor does it have Linux ARM packages yet. I do want to give a shout out that there is a provided Mac ARM developmental dependencies, so you can use that on your local to get the speed up from your ARM instance there, if you have an M1 or M2, I suppose. As well as different native dependencies that are needed. So as we know, our Python code is typically calling out to C++ machine code or even to the GPU. And these things require different base containers for different tools, as well as some of our tools don't really work on Linux ARM still at the moment. So there might not be packages available, wheels available for them. They might not be tested. And then, of course, working cross-architecture and having in your cluster a machine speaking to another that speaks, has a different instruction set could lead to some data correctness adventures. If you want to think maybe things like endianness of the data on one side or the other, the machine has to be able to interpret it correctly. You can potentially get silent errors, which are the most dangerous class of errors in terms of data. And then also, pip dependency resolution has made this harder, as pip can. As it got more intelligent, it's able to do more for you, but at the expense of speed and figuring out the dependency set. And now, why does this matter? Why do we care about doing this? My biggest focus for why do we care about doing this is cache. ARM instances can be up to 30% cheaper. That's money that can be then applied towards having more GPUs in your cluster. You can
or
use
bonuses, employee bonuses. That's the important place where the money should go.
Yeah, or bonuses. I would say probably bonuses and then GPUs. As well as we can avoid emulation when talking to edge devices that run ARM as well. A classic example of this would be if you're sending output to Android games, or edge devices could be cars, if you're sending large instruction sets to them. And then also, Ray datasets they're good, but they're not complete entirely. They can't entirely replace things like Spark and traditional tools like that. They only recently, for example, added key by operations, so that's your group by key, reduce by key, which many people really want. And as we know, most developers most likely want really just pandas at scale. Maybe not exactly the pandas API, but that is the ideal world if pandas could scale to thousands and thousands of nodes in an efficient way. Also, RAID environments are dynamically created, so that means that a lot of things are, if done in a normal way, are created as build time. So there's a compilation step, and that can be very slow on ARM, as there might not be a wheel available, so that code then needs to be compiled in the container before the actors can come up. That can add several minutes or quite longer hours to the time before the machine is actually up and running and able to do work, and that's time you're spending for compute that's not really computing anything of value to you. So you run into a situation where you say, I'm going to launch this TensorFlow pipeline, and it has to come up and do it. First, it might actually wind up compiling all of TensorFlow on every node in the cluster. Now that would be a way, so you have a 20-node cluster. Each one of them just did the compilation of TensorFlow. That's an obvious waste of money, and can add significant amount of time to a job that otherwise would take much less time. Now, so how do we solve this problem? Well, of course, we're running on Kubernetes, so Docker files. As one does with Docker files, they're trying to find out, making things work. So it can be a little sketchy in some of our examples, but the Ray community is thankfully working on making this better and providing KubeRay and other tools like that to abstract that away from the end user. So it looks more like just developing from your laptop to the cluster. But for us, we have Docker files that have a lot of well-specified dependencies, well-specified dependency sets, etc. And then also building from source, but doing that in a builder container, for example, so that doesn't need to be done when things come up, ensuring that when the machine comes up, the actors can start doing their work right away. And now one other way that people sometimes solve this when they want to have multiple tools is they just have a container for each tool, and they can be running in the same pod and then speak over localhost. So that's an approach that some tools take. Apache Beam takes that. You would have a tool, you would have a container for Spark, a container for Ray, they could speak to each other, but that has a lot of room for improvement with regards to performance as well as cluster utilization. Each of those containers is going to need to have a minimum amount of memory, maybe 4 gigabytes, 8 gigabytes, whatever, and if that could be all processed into one container, that would save, you could maybe half or, reduce by 20% or more the amount of compute that is needed for running the same job. And room for improvement is sort of what I think Holden said was her last performance review.
To be fair, I did not read my last performance review, so I'm just assuming it said room for improvement based on the fact that I didn't bother reading my last performance review. So, yeah.
All right, so let's take a look at some Docker files. So as we can see here, we did some, let me get to the, we had to make a number of updates. One thing you can see here that we do is fall back. So if a certain dependency isn't available because the architecture that this is compiling on is for, is going to be for ARM, for instance, you fall back using the OR statement. Other things we have is including we need multiple compilers to ensure that we have the compiler available for each. Even though those are included in the builder container, the final output actually still needs those because they need to be linked. But it still saves us time on building and setting up our whole cluster. So this is available online, and we will have links to that. Go. Now, so why does all of this still maybe take, you go to run this, you go to build it, it takes 2 days was our first attempt at doing this. 2 days was the compilation process. I thought my computer was broken for quite some time, but that was not the case. So one issue is that the new pip resolver does a much better job of handling dependency conflicts, so you don't have to specify versions as much, but that's quite a lot of work that it has to do. There's many versions of many packages, and navigating the whole DAG of dependencies to determine which ones fit together can take an extreme amount of time, as well as the way pip resolves. It actually downloads the dependency to check that if it'll work. So there could be quite a lot of downloading that takes place, and if that's happening regularly on your cluster every time you're running, that is a waste of compute. Additionally, ARM machines are very often lower powered CPUs.
Well, the ones I got for free. I got some free ARM machines with low power CPUs and big GPUs.
Exactly, and they would be having more focus on the GPU for doing the heavy lifting, but pip obviously doesn't use GPU acceleration for resolving dependencies, and the GPUs are only used for very specialized purposes. So we want to keep them used for just their specialized purpose and run everything else on x86 or compile it ahead of time as need be.
Yeah, cool. So there's different ways that we can solve this. We can cross-build things without using M1 or Tegra or an actual ARM machine. But if you're like, what sounds fast is emulating another architecture, that is not the case. This doesn't actually make it faster, but if you don't have one, you can run this high-quality fixqmu.sh shell script, only the finest, and it does a bunch of random things that I don't understand, but then after you run it, you can cross-build with Docker using emulation. The only downside is if anything touches Cgo, it will explode and not work. So that's great, but the good news is we don't touch anything in Cgo and Ray, so that's fine. And another one is we want to use CUDA, right? We want to be able to use our fancy GPU acceleration. But for me personally, I've got these Linux for Tegra machines, super wonderful machines, but they do take what could be described as a conservative approach to upgrading, also known as no. And so they're still on Ubuntu 18.04, and a lot of Ray's dependencies do not love Ubuntu 18.04, and so I do a bunch of terrible things to make this work, wherein I end up slipstreaming a bunch of different packages together, building in one environment and then running in another environment, and you get some really fun glibc errors, but eventually you can make it work. And if you like glibc errors, I don't know who hurt you, but I'm really sorry. But anyway, so that's fine. We can make it work, and looking at that Docker file is just going to result in sadness. So there's a link to it, but we're not going to go into it in too much detail. And the last one, which is a little funky, is making Jupyter notebooks work with Ray on Cube. And now we could, of course, try and just pip install Ray on top of the base notebook image, right? Or we could alternatively try and take the Ray container and then pip install Jupyter Notebook on top of it. It turns out that the second one kind of is what could be politely described as painful, because the entry points are super, super funky, and Jupyter Hub makes a lot of assumptions about how the container is set up. So it's not a simple matter of just like installing the Jupyter Hub extensions on top of your Ray container and just rolling a new one. So we actually found it easier to instead build a Ray notebook container where we essentially copied a bunch of the initial Ray container setup logic and ran it again on top of the Jupyter container setup logic, because the Jupyter container setup logic is a nightmare. But it's okay. It's a fun nightmare that you don't have to look at twice, because it kind of runs. And so there's different ways to deploy this. I think 0 to Jupyter Hub is the least painful way to get Jupyter running on Kubernetes. It's the one that I chose. There are different ways to do it, of course. If you don't like them, you can feel free to do that. Setting it up is a little bit painful because it turns out that you need to have this thing called authentication. And I have a funny story about authentication, which is namely, I'm lazy, so I didn't really want to set up an LDAP server. So I was like, what could I use for authentication? Well, there's a GitHub plugin. I could just set up a GitHub organization. And to be clear, this is like personal stuff, right? Like Glorious Employer has much better authentication, but in my own fun times, when I'm doing things, I need authentication because I don't want to end up mining cryptocurrency for some random person that isn't me, but also I don't really want to put a lot of effort into it. So I ended up using the GitHub OAuth authentication. And it's fun. Oh yeah, and then also, if you've ever said to yourself, what I really wish I could do is write Python with no syntax highlighting inline in a YAML file, I have news for you. 0 to Jupyter Hub can help that dream become a reality. Because it has, how would I say this? So it has really convenient hooks. So we can see here we've got this pre-spawn hook, and this is where I set the service account based on which user is logging in. Unfortunately, I have to do that inside of a YAML file, inside of some Python, and so that's just kind of not great and involved a lot of typos on my part, because white space sensitive languages and YAML files are a great mix. Anyways, mild sarcasm here. And then here's the GitHub authenticator. We can see I allowed it for everyone who's working on the Scaling Python book with me, or Scaling Python books with me. And then I didn't actually give you my GitHub secrets this time. I have live streamed them before and rotated them, but this time I did not. Funny story, the GitHub OAuth authenticator doesn't do a great job of knowing when you've hit your request limit. And so if you have multiple things using your GitHub OAuth keys, like say, for example, a PR dashboard, you might get into a situation where you just can randomly not log in sometimes, and you get very, very confused, and then it takes you 2 to 3 days. And this is some hypothetical person that definitely was not me. Definitely did not run into this problem. Okay, yes. Oh wait, it says I ran into this problem in my slides. So much for that lie. Okay, not the most convincing. Okay, yeah, and so like I was saying, we do this really funky thing. We can go look at the Docker file, but I do want to do the demo instead of scrolling through Docker files some more. But essentially, we end up layering Ray on top of the Jupyter container rather than the other way around. And so now we've got all of our fun containers, and it's time to use them with Ray. And the main thing is, like, we end up, it's pretty easy. All we have to do is override the image and operator image, and then we of course add our different worker groups. But this is really the only thing that we need to do that's specific to the multi-arch one. And that's just because the default Ray containers aren't available in multi-arch, so you have to build your own containers and then override the configuration to point to your custom containers. Oh yeah, and this other thing is because the NVIDIA GPU labeler doesn't run on the NVIDIA hardware that I got. I'm sure that makes sense.
And this one is running CubeRay in that example.
Yeah. But in practice, I ended up using Ray up because it was less of a pain.
Ray up.
Yeah. So what can we do with these fun containers, right? Like, what can we, and also what can I show you? Because I can't really show you like my employer's data. So we can do a bunch of fun things, including the finest logos from Fiverr.com. If you've ever said to yourself, wow, I wish I had an MS Paint license, Fiverr.com is the solution. No, more seriously. So I'm gonna run two demos. The first one is going to be the Space Beaver demo. And if you've ever said to yourself, I wish I had an open source satellite communication device that used the VHF frequency band and was super, super sketchy, I have a solution for you. And you should go to spacebeaver.com and give me your email address to definitely not spam, but contact with select unique marketing opportunities for qualified users like yourself. But yeah, we're going to run the backend for Space Beaver, and we're going to run this on Ray on a mixed architecture cluster. So the pre-work, aka stuff that takes too long to do live, is the first step is deploying a multi-architecture cluster. Now, you don't have to have a stack of hardware machines down in Fremont, California, like myself, to do that. You can run it on AWS, but of course I would encourage you to get a nice little colo cage down in Fremont, California, and then you can, clicky button, not clicking. There we go. And then we can see here, I've got like this really, really high quality K3S setup book. You can copy it and don't worry about it. Only the highest quality code. But that gives us a nice multi-architecture cluster, and then you build some multi-architecture Ray Docker images. I built one of them this morning, and let's hope that it works, because it only finished doing a push to Docker Hub during the previous talk. So I haven't actually, that doesn't look like it worked. Oh no, okay. Let's run this high quality shell script called deploy.sh. And I'm gonna comment out the part where we do the buildx because the conference Wi-Fi is kind of slow. Okay, let's see if this works. Let's see here, okay. Waiting for SSH to become available, which isn't actually SSH. We can go over here and we can look at the nodes. Okay, cool. So we've got a head node that's actually been up for 30 minutes. Interesting.
So I will say offhand, many times when speakers at conferences, not us, of course, say that these are sketchy and this is not a great way. It's oftentimes do as I say, not as I do. Of course, that's not what I'm saying is the case for us, but in practice, in production, at many places, you do wind up with some of these largely written out, what feels kind of hacky at the time, infrastructure pieces. And that can be holding up quite a large number of things.
Yeah. So we'll try this deploy one more time, and if it fails, we'll fall back to the second demo, which doesn't depend on satellites. So I'm sad because I was hoping to do the demo which we put in the book. But failing that, it's okay. We can do the Jupyter Hub multi-arch, multi-container demo. But let's see here. Get pods. Container creating. Okay. kubectl. Describe pod -n space beaver. What's it doing? Okay, it's pulling the image. So that's going to take a hot minute. So maybe while it's pulling the image, we'll do the other demo, and we'll circle back to this demo once it's done pulling the image. So demo number 2 is going to be, we're going to run Ray and Dask together on a ARM node. Ooh, so much fun. And so this is our this is our fun notebook. We can, okay. Kernel, restart and run all cells, and we can go ahead and we can see that it's actually running on an ARM node, and so we'll do that over here. jhub -o wide, and we can see Jupyter Holden K is running on Kate's worker NV3. And then if we go kubectl get nodes o wide, we can see K3s worker NV3 is running the 4.9 Tegra kernel. If you don't trust me, I can SSH to that machine. And and we can see it's got ARM processors in it, and so it's actually doing its thing, all kinds of fun. And we can see like it actually did start Dask on top of Ray, and so we have both of these installed in the same container, and it's working and being happy. And let's see if the other thing worked. Ooh, it looks like it worked. Okay, cool. We're going to do a hella fast demo. Okay, we're going to attach to this thing. Cool, we can see our actors have started. I'm going to go ahead and run tail-f temp. Oh yeah, I'll zoom in, sorry. Ray. Wait. There we go, session latest, logs. Okay, worker, star. Okay, cool. Okay, so you can tell this is a real demo because there's a bug in my code. Get message URL is undefined. I thought I fixed that. It's okay. It's not crucial. That just means the message won't actually make it to the satellite, but that's okay too. So what this high quality demo does is it sets up actor on Ray, and it sets up a SMTP server inside of the actor and exposes it as a service. And so we can go ahead. Ooh, okay, cool. Thankfully, it looks like I did telnet to that IP address before. Yay! And we can see it says like, hey, this is who I am. I'm the Ray worker. I'm running Space Beaver, PCF Labs LLC. And we can go hello, farts.com. Okay, mail from farts@farts.com. RCPT2 farts@spacebeaver.com. Data. Subject. Did you eat your beans? I am worried for your farts. Okay. And now we see here, message accepted for delivery, and then once again we can see this is an actual demo. It gives me an error for bad syntax because I pressed enter twice instead of once, but it's okay, it still accepted my message. And if we go over here, we can see that it turns out that there is no satellite user named Farts. So unfortunately, we cannot ask Farts if they ate their beans because they have not yet signed up for Space Beaver, but that's okay because you're gonna sign up for Space Beaver and get questions about your farts while you're in the woods. To be clear, that is not a message endorsed by my employer, in case you did not know.
Same.
It is a message endorsed by me because I think farts are hilarious. Okay, so why did we do this besides the opportunity to make fart jokes on stage? So both of our day jobs use Iceberg and Python for data adventures. Some of my day job does involve doing some fun stuff with Ray. It's kind of neat. It's not super my place to talk about the details of what we're doing at Glorious Employer. So that's why I showed a demo of my own stuff. I also got some free ARM nodes with GPUs. So shout out to the NVIDIA folks. Thank you for giving me free hardware. I don't know why you did that, but I appreciate it. And also, I have this Space Beaver project and a book called Scaling Python with Ray. And in all seriousness, if you do have like colleagues you're trying to get into Ray, I would really love your feedback or your suggestions sort of for what you're thinking about. We have a almost complete first draft of the book, and if you are willing to be like an unofficial tech reviewer, just take a look at it, tell us what might be missing, I would really, really appreciate that. And failing that, I would also really appreciate it if you bought several copies with your corporate credit card. And you can pre-order today on Amazon. And you can also help Jeff Bezos afford another newspaper. You know, that stuff's expensive. That stuff's expensive. Oh, and you should also give me your email addresses on spacebeaver.com so that I can contact you and definitely not spam about exciting opportunities to find out about farts. Okay, so the original plan had Q&A, but the original plan also had the demo not crashing. So you can find us in the hallway for any questions. And I'm sorry about the demo crashing, but that's how you know it wasn't staged. Thanks y'all for coming.